Let's talk today about the fundamentals of cloud computing. So, what exactly is cloud computing? Cloud computing is a computing mode that enables convenient, on-demand access from anywhere to a shared pool of computing resources. These services can be rapidly provisioned and can be released with very minimal interaction from the IT staff or service provider. There are 5 essential characteristics that define cloud computing. First, on-demand self-service. This allows users to access and provision the resources of the cloud automatically without requiring any additional human interaction. Second, broad network access. Capabilities are generally available over the internet through a standard portal that's accessible by any device that's connected to the network. Third, multi-tenancy. Multi-level control structures need to be in place that enable different organizations to securely share resource pools. Each organization can further control access to their resources. Fourth, rapid elasticity. This ensures that the cloud can scale to meet the level of user demand. And fifth, metering. This tracks the level of resource usage or the cost of that usage. Cloud computing can take place outside your company or inside your firewall. In general, the options are public, private, or hybrid clouds. A public cloud means that the cloud infrastructure is owned, managed, and operated by a cloud service provider and runs on its premises. A private cloud means that the infrastructure is owned, managed, and operated by an organization for its own use. Ownership, location, and operation can be outsourced to a third party, but the overall responsibility for definition of services and acquisition of physical resources remains with the enterprise. A hybrid cloud allows a user to access public and private cloud resources from a single management environment. In addition, there are 3 distinct types of IT services that enterprises both deliver and use today through public, private, and hybrid clouds. The first is software as a service, or SaaS, SaaS. SaaS enables users to access an application, but they have little or no control over the delivery of the application. An example of SaaS is Gmail or Salesforce.com. The second is Platform as a Service, or PaaS, PaaS. Platform as a Service enables users to deploy infrastructure applications onto the cloud through a framework of programming languages, libraries, services, and tools that are supported by the provider. The user has control over the deployed applications and may also have some control over the configuration settings for the application hosting environment, but they don't control the underlying infrastructure. An example of a public PaaS is Windows Azure or Cloud Foundry. An example of a private one is the Windows Azure Platform Appliance. The third cloud service, and the one that's most widely viewed as a cloud, is Infrastructure as a Service, or IaaS. An Infrastructure as a Service cloud enables a user to dynamically provision computing, storage, networking, and other fundamental computing resources, where the user does not manage or control the underlying infrastructure. To understand how Infrastructure as a Service came about, let's go back in time about 10 years. At that time, if a business user wanted a new service, they had to ask IT to provision a server for them. Back then, that typically meant installing a physical server, which could take weeks and require a capital outlay. In today's environment, most data centers are highly virtualized, but it can still take 1 or 2 days, maybe even a week, to provision that virtual machine, and potentially even longer to get the necessary authorization. That's because you got to find capacity on a server somewhere, you got to set up the machine, and then you have to build and deploy the image to the machine. The result? The line of business thinks IT is unresponsive, IT thinks the line of business is too demanding, and the delays cost the business money. Public infrastructure as a service cloud offerings, most notably Amazon but also Rackspace, grew rapidly because of this need for on-demand computing resources that internal IT departments weren't capable of providing quickly enough. They provided a solution where any individual or company, large or small, could provision a server themselves when they needed it, run it for as long as they needed it, and then shut it down. Because these public cloud providers purchase hardware and software and run the infrastructure in their data centers, companies have no upfront capital expense. They pay the cloud service provider an ongoing operational cost for only the computing resources that they need. Initially, enterprises were looking at public infrastructure as a service providers as a way to get access to compute resources for a short period of time without paying the upfront capital expense of a server. But once people started using infrastructure cloud computing, they recognize the other benefit, being able to respond more rapidly to changes in demand. This was really nice if, for example, all of a sudden your website had a lot more traffic on it because of a promotion you were running, or because your business was featured in the news. If you're running on a traditional IT infrastructure where you're managing servers on a server-by-server basis, it can be really hard to respond to those changes quickly. On the other hand, in a cloud, it's relatively simple to say, oh, hey, I need 3 more virtual machines, and you spin those up. You deliver the capacity that you need so you can handle that peak in demand quickly and easily. This notion that the business could be more agile started to get the attention of enterprises. Both the IT organization and the line of business were really excited about the value they saw. Once enterprises started to see that value, they started to look at how they could build their own cloud-type infrastructures inside the firewall, a private cloud. A private infrastructure as a service cloud helps an organization better control security of data and ensure compliance with regulations. It also makes much more efficient use of the enterprise's physical infrastructure. In a physical server-only environment, an enterprise is lucky if they get an average of 25% resource utilization. In a virtualized environment, this may push the resource utilization up to the 50% range. Cloud computing, with its increased levels of automation, promises to get utilization to 75% or even higher. By increasing the overall utilization of their servers, enterprises should be able to drive down capital expense. At the same time, the computing environment becomes more productive by allowing system administrators to manage a larger number of virtual servers than they otherwise could have. This provides enterprises with long-term operational expense savings as well as capital expense savings. Cost aside, enterprises can react much more rapidly to reconfigure their environment, responding quickly to changes due to external or internal events. A private cloud makes it much easier to shut down certain workloads or rapidly deploy new workloads. Rather than having to create new capacity or install new servers, you just start up some new virtual servers and you reallocate the resources in your cloud. That's much easier to do in a fully virtualized private cloud environment than with partially virtualized or physical environments. And enterprises can do this in-house, where they control the data and the security, and where they can minimize compliance risks. Whether deploying workloads in a public infrastructure as a service cloud environment or in a private one, or in both, enterprises have the ability to develop a more flexible and agile infrastructure that better aligns to the needs of the business while reducing costs. To understand how Suse can help an organization enjoy the benefits of cloud computing, please visit www.suse.com/cloud solutions.